Welcome to the deep dive. This is where we, take the sources you give us and really explore what's going on. Today, we're diving into something truly mind-bending. Supermassive black holes.
Ah, yes, the real giants of the cosmos.
Exactly. Not just big, but maybe the most influential things shaping entire galaxies. So our mission today is to unpack these cosmic architects. And just to be clear right off the bat, we're not talking about your regular stellar black holes, the ones from collapsed stars.
Oh, not at all. The scale is completely different. It's almost hard to grasp. We're talking millions, sometimes billions, of times the mass of our own sun. It really makes you think, doesn't it?
Yeah.
About the universe and, well, where we fit in.
Billions. Okay, so where are these things? Are they scattered everywhere, or do they have specific hangouts?
They tend to prefer prime real estate. You find them right in the centers of most large galaxies. Think of it like a massive dark heart, and everything else, hundreds of billions of stars, is sort of dancing around it.
Including ours, the Milky Way.
Yep, including our own Milky Way. Definitely.
Wow. Okay, so tell us about ours. What do we know?
Ours is called Sagittarius A. That's A star. It's about 26,000 light years away, right slap bang in the middle of the galaxy. And it packs roughly 4 million times the sun's mass into an incredibly surprisingly small area.
4 million solar masses. How did astronomers even figure out it was there if it's, a black hole?
Right. Well, they did it indirectly. They watched stars really close to the galactic center, and these stars were just whipping around at unbelievable speeds, orbiting something invisible.
So the motion gave it away.
Exactly. The gravity needed to make stars move like that. The only explanation that fits is a supermassive black hole, a real behemoth.
Okay, so if they don't come from just one star collapsing, which is how we usually think of black holes, then how do they get so incredibly massive? That seems like a pretty fundamental question in cosmology.
Oh, it's absolutely one of the biggest mysteries we're wrestling with. There isn't one single answer yet, but there are a few main theories. One idea is they started as seeds, maybe primordial black holes that formed, like right after the Big Bang.
Primordial, so not from stars at all, just left over from the beginning.
Potentially, yes. As old as the universe itself, practically. And they just grew over cosmic time. Or another possibility is they built up more slowly. Imagine thousands of smaller, stellar mass black holes colliding and merging over billions of years.
Like cosmic raindrops forming an ocean.
Sort of, yeah. A very, very gradual process. Or a third option is maybe huge clouds of gas in the very early universe just collapse directly into a massive black hole, skipping the whole star phase.
So ancient relics, slow mergers, or massive direct collapses. It sounds like we're still piecing that puzzle together.
We definitely are. Observing these things happening is tricky because of the immense timescales involved. It's an active area of research for sure. Different paths might even lead to different types of supermassive black holes.
Okay, so we've got this giant Sagittarius A at the center of our galaxy. You mentioned it's relatively quiet.
Yes, thankfully for us, it's not actively feeding very much right now. It might sort of snack on a gas cloud now and then, or maybe an unlucky star that wanders too close, but it's generally pretty calm.
But that implies some aren't calm.
Exactly. Some supermassive black holes are incredibly active, and when they are actively feeding, they can become, astonishingly, the brightest objects in the entire universe.
Hang on, wait. Brightest, but they're black holes. They're supposed to be dark, right? That sounds like a paradox.
It does, doesn't it? And it's a great question. The black hole itself, the singularity in the event horizon, yeah, that's dark. But the light doesn't come from inside the black hole. It comes from the material falling towards it.
Oh, okay.
As gas, dust, even stars get pulled in by that immense gravity, they don't just drop straight in. They form this huge swirling pancake of material around the black hole. We call it an accretion disk. And this disk is spinning incredibly fast, like near the speed of light. Yeah. And the friction within that super fast, super dense disk heats the material up to millions, even billions of degrees. Unimaginable temperatures.
Okay, so it's friction heating up the stuff falling in.
Precisely. And that superheated material just glazes, radiating enormous amounts of energy light, X-rays, radio waves, the whole spectrum. It can outshine the entire host galaxy, trillions of stars combined.
So it's like a lighthouse powered by destruction as the material gets torn apart and heated up.
That's a fantastic way to put it. A lighthouse illuminated by destruction. And these incredibly bright, active galactic centers, we call them quasars. They are so unbelievably luminous we can see them clear across the observable universe. They're like beacons from the dawn of time.
That's incredible. So basically, at the heart of almost every big galaxy, there's this sleeping monster, this
Yeah.
silent engine that could become the brightest thing imaginable if it starts feeding.
That's pretty much the picture, yeah. And it goes even deeper. They aren't just destructive. They're also, in a way, sculptors, architects of the cosmos.
How so? What do you mean?
Well, their gravity is fundamental in shaping the structure of the galaxy itself, holding things together, influencing orbits, and the energy blasting out from them when they're in that quasar phase. That can actually affect star formation throughout the galaxy.
Affect it how? Like, trigger it or stop it?
Both, actually. Sometimes the outflows can compress gas and trigger bursts of star birth. Other times, they can blow the gas right out of the galaxy, shutting star formation down. They're regulators.
So they really are central players, this dark heart that's both creative and destructive, and everything kind of revolves around it.
You've got it. They're fundamental to how galaxies evolve over billions of years.
Yeah.
We wouldn't have galaxies like the Milky Way without them.
It's truly mind-boggling when you stop to think about it. These cosmic architects and destroyers right there at the center of it all. We've definitely covered a lot today, really getting into the heart of these silent giants. It just shows taking this kind of deep dive can uncover some really profound stuff for you listening in.
It absolutely does. Maybe a final thought to leave you with.
Yeah.
Consider these immense silent engines driving the whole cosmic dance. It makes you wonder what other vast fundamental forces are out there, shaping reality in ways we haven't even conceived of yet. There's still so much unknown.
A humbling thought indeed. Keep looking up, keep wondering. Until next time on The Deep Dive, dream of the cosmos.